What the? Look! Do you see this? Part of the sun has broken off, and it's now churning above the star's surface, having formed a giant vortex. What's going on there? Well, let's admit it. We still know very little about the sun, however crucial this star is for our well-being. But in the case of the broken sun, scientists can probably explain what happened. Some of the star's plasma likely erupted from the sun's surface and broke away, creating something resembling a crown-like vortex over the solar North Pole. And still, this is just a theory. Astronomers need to conduct further analysis to figure out if this is what really happened. At the moment, they're a bit baffled, since this phenomenon is nothing like anything they've seen before. But the footage we've got is undeniably impressive. What is more alarming, though, is that the behavior of our star is currently changing. The sun is ramping up its activity. It's getting rowdier with flares and sunspots. This year, it's flared every day so far. It's also thrown up a few X-class and M-class flares in January of 2023. These flares are the largest and second largest eruptions our star can produce. Even though it sounds kind of alarming, don't worry. The sun has certain activity cycles that repeat every 11 years or so. Some of them are relatively calm, while others are absolutely wild. These cycles happen simultaneously with the fluctuations in the sun's magnetic field. When it gets the weakest at the star's poles, they switch places. This makes the polarity of the magnetic field reverse. This is the very period of time when the sun is the most active. It's known as solar maximum. Right now, we are near this solar maximum. Scientists can figure it out by analyzing unusual solar activity. But since the sun is still pretty much a mystery to us, no one can determine when the polarity reversal is likely to occur. A rough estimation is July of 2025. At the same time, we can't say that the current solar situation is normal. It's true that each sun's cycle is different from others. Some are weaker and some are more powerful. So this one, which started in December of 2019, has already significantly exceeded all scientists' expectations and keeps doing so. Which brings us back to the vortex observed on February 2nd, 2023 that impressed astronomers so much. It started as a solar prominence. This is a bright plasma filament extending away from the surface of the sun. And, let me tell you, solar prominences are an absolutely regular phenomenon. And like the most recent one, they often occur at high altitudes around the sun's crown, which is the outermost layer of the star's atmosphere, also known as the corona. Anyway, prominences like the one in question are called hedgerow prominences because they look like a hedge. But what surprised astronomers happened a bit later. The material of the filament apparently broke away and started circling the pole near where it occurred at 60 degrees latitude and at a speed of about 60 miles per second. And it lasted for about 8 hours. One scientist, who has been observing the sun's cycles for decades, claims that he has never seen vortices like that. Unfortunately, solar poles are very difficult to observe, so it might be a while till we get our answers. For the first time, a spacecraft touched the surface of the sun in 2021. It was NASA's Parker Solar Probe that flew through our star's upper atmosphere. It also took some samples of particles and examined magnetic fields there. It was a real milestone and a giant leap for solar science. Getting their hands on the very stuff the sun is made of will allow researchers to uncover crucial information about our star and its influence on us and the entire solar system. The Parker Solar Probe moved closer to the sun's surface and started making discoveries that other spacecraft were too far away to see. For example, the probe examined the solar wind from within. It's a flow of particles coming from the sun. These particles can influence us here on Earth. Even before coming super close to the star, the Parker probe found out that near the sun, there were loads of magnetic zigzag structures in the solar wind called switchbacks. But at that time, scientists couldn't figure out how they formed and where they appeared. But now, more than 2 years later, we know for sure that switchbacks originate at the solar surface. As you know, the Sun doesn't have any solid surface, unlike our planet, but it has a superheated atmosphere, which is made of solar material bound by magnetic forces and gravity. When pressure and rising heat push that material away from the star, it eventually reaches a point where the Sun's magnetic field and its gravity can't contain it anymore. This point has its own name, the Alphane critical surface. It marks the edge of the solar atmosphere, and that's also where the solar wind begins. The material that manages to make it past the boundary turns into the solar wind. It drags the Sun's magnetic field toward Earth and beyond. But the most important thing is that past the boundary, this wind starts moving so fast that its waves can't return back to the Sun, which literally means severing all connections with the star. During its flyby, the Parker probe passed inside and out of the Sun's corona several times, which proved that the Alphane critical surface wasn't shaped like a smooth sphere. It has valleys and spikes, and its surface is kinda wrinkled. At one point, the probe even came across a pseudo-streamer. These are massive structures in the Sun's corona that rise high above the surface of the star. You can see them from Earth during solar eclipses. And you know what? For the Parker probe, passing through the pseudo-streamer was like flying into the eye of a storm. Inside, everything was much quieter. Particles moved more slowly, and there were fewer switchbacks. It was a huge change from the barrage of particles the probe encountered inside the solar wind. Now, speaking of solar flares, those are pretty dangerous for Earth. The radiation they release can interfere with our radio communication. Such storms affect all electronic systems, from the internet to power grids, and can even destroy satellites. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares that people should be worried about. They cause the strongest and longest-lasting solar storms. A super strong solar storm heading toward Earth won't happen at once. First, there will be high-energy sunlight, mostly ultraviolet rays and X-rays. They will ionize our planet's upper atmosphere and mess up radio communication. After that, a radiation storm will hit Earth. And finally, a colossal cloud of charged solar particles will reach our atmosphere. The particles will interact with the planet's magnetic field and wreak havoc all over the world. If an intense solar storm happened these days, it would start by disrupting GPS and knocking out satellites. If any astronauts were spacewalking at that moment, they would have mere minutes after the first flash of light to find shelter. Their spacecraft would likely be properly shielded and safe enough. The main challenge would be to get inside in time. After that, the storm will proceed to interfere with satellite communications. That's why tons of your daily activities, from calling your friends to paying with your credit card, would be at risk. But one of the worst consequences would be connected with power grids. Power surges caused by the particles coming from the Sun would damage giant transformers. A powerful solar storm could cost people $1 trillion to $2 trillion. Luckily, if such a powerful solar storm was heading our way, we'd most likely get some kind of warning. Modern equipment all over the world and in space doesn't stop watching the Sun even for a second. It would give us some time to prepare, between several hours and a couple of days. And if transformers were taken offline in time, the consequences wouldn't be so dramatic. Is it possible for a planet to have not one, not two, but many suns? Let's imagine what would happen to us if the sun suddenly decided to break into a bunch of small stars. During the search for Earth-like planets throughout the universe, scientists have discovered that systems of 2 or even 3 stars are not actually that rare. Many of them even have planets in their habitable zones. Almost half of these planets could contain life. Can't wait to ask these guys about the sunsets. Scientists even suggest that our sun wasn't always lonely. It could have had a companion star called Nemesis. They've noticed that mass extinctions on Earth occur every 27 million years. It's like a cycle. So they turned to the stars to find out what the reason might be. And then they assumed that it was a star that left our sun a long time ago, but it still affects us. Nemesis could be located about 1.5 light years from us. It may not sound like a lot, but it's actually almost 9 trillion miles. That's going to be a fun car trip, 50 million years long. Anyway, every time Nemesis passes its orbit, it can affect the Oort cloud. The Oort cloud is an area surrounding our solar system in which comets are formed. Its existence hasn't yet been proven, but scientists are pretty sure about it. So, comets form inside this cloud and then relocate to our solar system. Even being very far away, the second star in the system can have a great influence on it. But what about systems with 4 or even more stars? Is it even possible? Actually, yeah. But the more celestial bodies you add to the system, the more difficult it becomes. The orbits grow unstable. It's gonna be as chaotic as can be. In stellar mechanics, it's called the 3-body problem. It says that it's very difficult to predict the orbits of bodies in such systems. In most cases, they turn out to be very random and unique. Isaac Newton was the first to have noticed it. He tried to apply his gravitational discoveries to the Earth, the Moon, and the Sun. He found himself with quite a struggle. It wasn't easy to understand how 3 stellar objects orbit so stably around each other. And that's just a planet and a satellite. How about including several stars? I wouldn't envy those who will have to calculate all this. Oh, right, it's me. Anyway, we know that triple star systems are ridiculously chaotic. But what about systems with more stars? They're very, very rare. In 2021, NASA discovered a star system of as many as 6 stars. That's just crazy. Of course, there are no planets in it, but who knows? Maybe one day we'll find such a system too. In such worlds, the gravity dance is very complex. It takes very specific conditions to hold everything together. It's like walking on a tightrope over an abyss. With all this in mind, let's try to imagine what would happen if the sun suddenly turned into several small stars. Oh, we're going to need a very detailed simulation. No, probably even a dozen simulations to make this thing work, because otherwise, we'd only have a few options. Option 1. We divide the sun into 5 to 10 tiny suns. Now we'll scatter these guys not far from each other. They'll destroy our system in a couple of hours. Yeah. All star systems, including ours, are in constant motion across the universe, so they'll crash into each other almost immediately. This collision will lead to the creation of a supernova. Our system will turn into a beautiful, colorful nebula. For us, it will happen in just a couple of minutes. We won't even have time to feel anything. And all the planets in the X solar system will immediately turn into sparkling space dust. But it's not the best option for us, right? Let's see if it can go any other way. Option 2. Since they can't be located so close to each other, let's try to set them as far away as possible. And in this case, they'll just leave. Bye-bye. Their gravitational force is too weak to hold everything together. The little suns will simply leave the solar system, flying into space in random directions. After that, the rest of the planets will descend from their orbits, including poor little us, of course. We'll become a so-called rogue planet. At first, we won't even realize that the planet has gone out of orbit, and we won't have time to do anything before it gets incredibly cold. What a sad and poetic end. In general, none of these outcomes sounds very fun. Oh, alright, we still have the last option. Our main problem is that we make each of these little stars the same mass. But just take a look at all these multi-star systems that we've already discovered. You'll see that none of them look like a bunch of glowing balls together. Instead, there are a couple of large stars there, and the rest, the small ones, are orbiting around them. So how about 2 large stars and 2 small ones? What will the Earth look like then? Well, its orbit will become terribly unstable. We'll shake back and forth. Wouldn't recommend it, honestly. We know what this can lead to because, and that's just crazy, this has already happened to us once. Yes, about 70,000 years ago, a lone star visited our solar system. It was a red dwarf called Scholz. A red dwarf is a very small and cold star, if you count 14,000 degrees Fahrenheit as cold, of course. But it's considered the weakest and coldest type of star, so it probably didn't look that big and bright in the sky. At that time, our ancestors, Homo sapiens, were already there living their lives. And can you imagine? They saw another star in the sky approaching the sun. I wonder what that looked like. And then, Scholz bypassed the sun and flew somewhere further to surf space. You weren't expecting some kind of disaster, were you? If it had happened, you wouldn't have had a chance to watch this video right now. But from this story, we can see what happens to the Earth during such stellar events. At that time, a huge amount of volcanic activity unfolded on our planet. We also got some meteor showers that almost wiped us out. Our ancestors sure had it rough. Something similar will happen on our hypothetical planet with 4 suns, but on a much greater scale. Constant volcanic activity, earthquakes, and tsunamis. Brr. In addition, the length of a day will change, as well as the length of all seasons, and a year as a whole. They won't be stable anymore due to the regular changes in gravitation. In other words, you'll never know when to expect an annual winter or hot summer. And when we are precisely in the middle between 2 stars, there won't be any nights at all. They'll illuminate both parts of our planet, and we'll have to sleep in bright sunlight. And if you think this is a bad thing, keep in mind that we'll also be attacked by much more ultraviolet rays and solar winds because of our 4 suns. Their color will also change. They'll become red dwarfs, looking distinctly orange-scarlet in the sky. We'll also get many more solar eclipses, except instead of the moon, the sun would be eclipsed by another sun. It would probably just get a little darker. To be honest, it's unlikely that anything would survive on Earth after all this. I mean, it is possible, but please run 100 simulations yourself if you want to make sure. But theoretically, we could survive in a simple binary star system. For example, in one that consists of 2 stars close to each other. Each of them would have to be 2 times smaller than our sun. That would be the perfect scenario. And it's quite possible in the future. NASA is currently working on a plan to relocate our descendants to Proxima Centauri b. That's a planet near the closest star system to our sun, Alpha Centauri. And who knows, maybe one day in the future, we'll really move there. Then we'll see what it's like to live with several suns.
So, what's going on with all the news about the sun? Some say that the sun is getting angry. Well, what does that mean exactly, and should we be concerned? Frankly, yes, we should be concerned. It's generally not a good thing to get too much sunshine. The ultraviolet component of sunlight is harmful to the skin. That's why humans have adapted a spectrum of skin pigmentation. The more sunlight there is to protect ourselves against, the more pigmentation we need. Big floppy hats and, of course, bottles of high SPF oil-free sunscreen help too, especially for fair-skinned people. But what is planet Earth going to do? First, let's get a good estimate of just how angry the sun is likely to get. The sun usually goes through an active-calm-active cycle every 22 years, with highs and lows occurring every 11 years. Why that happens, no one knows, it just does. There's probably a reason, but scientists haven't figured it out yet. They do know that, with each cycle, the sun reverses its magnetic poles. That in itself is pretty astounding, especially when you consider that Earth hasn't reversed its magnetic poles in the last 600,000 years. Lately, the sun has been extremely calm, the calmest it's been in over 100 years in fact. That's unusual too. The active-calm-active cycle has turned into an active-calm-calm cycle. But that's changing, and it's why we are notifying Brightsiders about what to expect in the coming few years. The terms calm or active or angry refer to the amount of high-energy radiation that the sun gives off. Thankfully, the amount of visible light the sun gives off doesn't change very much. That would be a serious problem. If the sun were to get just 6% dimmer or brighter, the Earth would either freeze or fry. Observing sunspots is the easiest way to measure how active the sun is. The more sunspots that are visible, the more active the sun is. A graph, known as the butterfly diagram, tracks the 11-year period of sunspot activity. The butterfly diagram shows how sunspots disappear regularly from the surface of the sun and reappear regularly in other locations. NASA predicted that the present cycle of solar activity would be calm, like the previous one. But it's starting to look like that is not the case. Presently, we are in solar cycle number 25. That's the 25th 11-year solar cycle since 1755, when record-keeping began. This cycle of solar activity is expected to peak in 2025. The sun has already exceeded the number of sunspots NASA had predicted. So, it doesn't look like this solar cycle is going to be a calm one. It looks like we are going to have some very active sun-blasting radiation on Earth for the next several years. In early February 2022, 40 out of 49 SpaceX communication satellites in orbit above the atmosphere were destroyed by an explosion on the sun. High-speed electromagnetic plasma gas from the sun, known as solar wind, caused the Earth's atmosphere to compress, and Elon Musk's satellites lost their orbital integrity and crashed back into Earth. Sunspots look like dark spots on the sun, but they aren't dark. They're just not as bright as the surface of the sun. To get a better idea, take a lit 25-watt light bulb and hold it in front of a lit 100-watt light bulb. The 25-watt light bulb will appear dark. That's the same way it is with sunspots. Sunspots on the surface of the sun almost always come in pairs. This is because sunspots are magnetic storms in the plasma gas of the sun. One sunspot will be magnetic positive, and the other sunspot will be magnetic negative. Between the two sunspots, which can be many times bigger than the Earth itself, there flows an electric current that carries a fiery arc of ionized gas with it. Solar flares are something else we should be concerned about. They are powerful electromagnetic explosions on the sun associated with sunspots. As the superhot plasma gas on the sun churns and twists, it also twists the magnetic field lines in the sunspots. When these lines snap, a powerful explosion releases X-ray and gamma radiation at the speed of light. Visible gases are also released. Solar flares have a classification system according to how powerful they are. X-class solar flares are the most dangerous. This type of solar flare can cause radio blackouts across Earth and harm satellites, astronauts in orbit, and even passengers on high-altitude airplanes. M-class solar flares cause spectacular aurora at the North and South Pole areas on Earth, while C-class solar flares have almost no effect on Earth. But solar flares are not the biggest explosions on the sun. CME stands for coronal mass ejection, and these are much more massive than solar flares and more dangerous when they're headed our way. As the name indicates, coronal mass ejections are explosions that originate on the sun's corona. They hurl millions of tons of hot ionized gases outward from the corona. The word corona is derived from the Latin word for crown, and it's the layer of thin bright gas around the sun's surface. The corona of the sun is much hotter than the surface of the sun. The surface itself is about 10,000 degrees Fahrenheit, but the corona is somewhere between 1 to 2 million degrees. The why and how the corona is so much hotter than the surface of the sun is another major mystery that scientists have yet to completely work out. A recent theory claims the corona is heated by sound waves and the sun's nuclear reactions make a lot of noise. Project GONG, which stands for Global Oscillation Networking Group, was set up on Earth to monitor the sound waves on the sun. Cool, huh? Turns out the sun is ringing or oscillating like a bell. and we have 5 observation sites across the globe. One in India, Australia, one in the Canary Islands, one in Chile, and one in California that keep a constant watch over the 10 million sound waves moving on and around the Sun. Now that the Sun is entering an active phase, we can expect to see more powerful CMEs heading our way. The gases expelled by the Sun are ionized and stripped of electrons by the intense heat. This causes them to form a proton storm that can travel through space at speeds of around 500 miles per second. These positively charged atomic nuclei will mostly be blocked or deflected by the magnetic field that extends around Earth. Our atmosphere is no help against a proton storm, although the last mile of air above the surface of the Earth stops the harmful X-rays from solar flares. The particle wind from the Sun can only be stopped by Earth's magnetosphere. We can look forward to some spectacular aurora around Earth's magnetic poles, and it's very possible that these aurora will extend down to the mid-latitudes when the Earth is moving through a coronal mass ejection. Currently, the United States has a space probe headed for the solar corona. Because the corona of the Sun extends outward for many millions of miles, the Parker Solar Probe, as it's called, is cruising 3.8 million miles from the surface of our star, or about 1/10 the distance to Mercury. The probe is experiencing temperatures of 2,400 degrees Fahrenheit, but it is also kept at perfect room temperature. A 4.5-inch thick carbon composite heat shield protects the telescopes and magnetometers in the probe that measure the intensity of the solar wind. The 5 antennae that protrude into the coronal gases are made of a niobium alloy, which can withstand the extreme temperatures of the corona. The recent double calm cycle of the Sun is a bit concerning when trying to predict how active the Sun will get this cycle. The sunspots completely disappeared for a long time from the entire surface of the Sun. It is as if the magnetic distortions we usually see on the photosphere of the Sun had collapsed into its interior. Intense magnetism is coming to the surface now and breaking through into the corona. The National Center for Atmospheric Research in Boulder, Colorado, is predicting that this solar cycle, cycle number 25, will be one of the strongest ever. The last solar cycle was very calm, with a sunspot count of only 116. The average is 170. But the prediction for this cycle is between 210 and 260 sunspots, which would be one of the strongest cycles ever. We stand to lose more satellites to a stronger solar wind. We can also expect electric grid overloads as the proton storm peaks in 2025. That means we should expect an interruption to our internet services as positively charged protons get into the wires, run into the transformers, and overload them. On March 12, 1989, a powerful CME hit Earth and created absolute havoc with our power grids. Will we experience anything of this magnitude in the near future? Well, stay sharp, Brightsiders.
What would happen to us and our planet if it became as big as the Sun? The diameter of the Earth is 8,000 miles. Crossing it is like driving back and forth across the USA 3 times. That doesn't sound like much, right? Well, how about repeating this journey 305 more times? Just imagine the gas expenses. This is the diameter of the Sun, about 865,000 miles. Compared to our Earth, the Sun is unimaginably huge. So what will happen to us if we catch up with it? There are 4 possible scenarios, depending on what we mean when we say the size of the Sun. Scenario 1. The Earth becomes as large as the Sun, but its mass remains the same. A colossal planet with the mass of a teeny tiny Earth. First, say bye-bye to gravity. The more massive the planet, the stronger its gravity is, and vice versa. Such a lightweight planet simply wouldn't be able to attract anything to itself. Gravity creates all the heavy substances. Everything, from pebbles to entire continents, is held thanks to it. I believe you've already guessed what would happen without it. We'd all turn into dust particles. Yes, the Earth simply becomes a dust cloud. Oh, and to add fuel to the fire, the gravities of other planets stretch us to the sides, leaving no chance to collect our planet back together again. This scenario doesn't look very good, does it? By the way, even if the Earth somehow remained a planet, life couldn't have originated on it in these conditions. There would have been a considerable distance between the center of the Earth and its surface. And remember, the planet's mass is minimal, so no gravity. It just wouldn't be able to hold the atmosphere. And without the atmosphere, living organisms cannot develop. Not like it would have mattered. The Earth now is a cloud anyway. So now this cloud, weighing about 10 times heavier than Jupiter, is gathering in space. As a result, it collapses and turns into a star. Say hi to the new sun. Scenario 2. This works both as a separate scenario and as a result of the previous one. The Earth becomes as large as the sun and gets its mass. Now we have two suns. We become a so-called binary star system. You know what that means? It's time to destroy our entire solar system. Imagine having two centers of mass in one system. The planet's orbits become unstable, perturbed by such a sudden change. Once they get closer to our ex-Earth, they collapse immediately, either from tidal forces or the ex-Earth's impact. Yes, even gas giants. Looking at you, Jupiter. Do you know which one survives and finally gets its revenge on us? Pluto. It would probably be the last remaining X-planet in the entire system. It's too far away to notice any changes, except for an increase in the mass of the center of the system. So Pluto's orbit comes closer to our two-star system, and that's it. The Earth and the Sun would have to accept that Pluto would be their only friend now. The protoplanetary disk that formed our system billions of years ago doesn't exist anymore, so no more planets can be created in our system. That's all well and good, but what about the Earth itself? What would life be like? Let's see. The nights and days now last longer because of the increase in the Earth's rotation time. There is probably a significant temperature drop in the North and South poles. Even on our current small planet, they get sunlight scarcely. So if the Earth's size increased, the area of the poles receiving sunlight would decrease even more. On a positive note, there's a lot more space now. No more overpopulation. The planet's size is so huge that it would take you years to get from one point to another. Yeah, if you think about it, we'd probably be very lonely there. But hey, who knows? Maybe rockets would become our primary means of transportation. Yeah, that would have been cool. There are many vast uncharted areas that no human ever saw or visited. We also wouldn't know about the existence of many different civilizations and tribes. Centuries pass, and many of us go away without ever meeting other people or learning about them. And that's if we can walk at all. Our bones cannot support our weight with such a considerable gravity, and our hearts have to work twice as hard to keep us alive. The birds can't fly anymore. Nothing can, precisely. All the existing trees fall down, and the new ones grow very close to the earth, like grass. Talking about the trees, how is our ecosystem doing? Well, not good. If we don't appreciate the environment on our small Earth right now, imagine what would happen if we had such a massive space at our disposal. I even assume that our tons of garbage would have overpowered even those endless supplies of trees and clean water that we would have in our new large home. Our machines and robots have to be huge to do at least something now. That's because even ordinary farms now are the size of the US states. I also assume that it would be much darker than we're used to. The Earth is so small now. Imagine what would happen when our planet becomes the size of the sun itself. Less sunlight means that we'd probably need an artificial sun. Also, the temperature differences on the planet's surface would be huge. If you're surprised, you probably underestimated the size of the sun. It's almost 110 times larger than the Earth. Our new Earth's equator equals our current Earth's 35 equators. Oh, and remember Pluto? Well, it's our only moon now. The first one would have probably crashed into us a long time ago. making us share the fate of the dinosaurs. In that case, all the water would likely evaporate from our planet. Anyway, there are thousands of bad possibilities, but let's just move on and focus on something good. Scenario 3. Same thing, but the Earth retains its density. Now this one is interesting. We're no longer a planet. We're a star now. In fact, we became even more massive than the Sun. Our planet now has a 3.9 solar mass because we need to balance our low density somehow. In short, it would be almost the same as in Scenario 2, but with more interesting long-term consequences. Since our Earth became 4 times as massive as the Sun, it would have burned its fuel quicker. Then it would evolve, and depending on the mass of its core, it either becomes a supernova or just blows off its outer layers to form a planetary nebula. If it goes supernova, the Sun that was so close to us blasts, and now there is just our ex-Earth, a lonely ball with a teeny tiny diameter of 12.5 miles. We're a neutron star. That is, a star made of degenerate neutron matter. That thing is ultra dense and spins very quickly, so you'd better stay away from it. If the Earth becomes a nebula, the Sun collects all the dust and adds it to its mass. Now we have a slightly more massive Sun and a white dwarf. The time passes, and Grandpa's Sun lives out his life. It becomes a red giant after depleting the hydrogen in its core. It starts expanding and leaves its material, mostly hydrogen, on the white dwarf. That's us. When the matter reaches high enough temperatures and pressures, nuclear fusion happens. We become a nova. Yay, we're a star again. A lonely one, but a star nevertheless. So what happens next? You see, a star is a battle of opposing forces. One of them is gravity, which tries in every possible way to compress the lead into a small ball as much as possible. The second is a pile of fuel in the star's core, which, while burning, forms tons of energy and substantial hot temperatures. As long as these forces are in balance, the star lives. But when the star's fuel runs out, the star cools down. The pressure inside it drops. This means gravity has won. It squeezes the star with all its might, and as a result, the star goes, hooray! In just 15 seconds, the brightest light you've ever seen in your life flashes, and our ex-Earth goes supernova, leaving a stunning nebula behind. Anyway, don't worry. It's actually impossible for a rocky planet to be the size of the Sun. Only other stars can be that large. But wait, why is our Earth so small while the other planets are enormous? Do they just keep growing, or do they stop at some point? The more mass you add, the more compression you get. As planets become more massive, the gravitational compression increases. They stop growing when their mass reaches roughly 1.7 times that of Jupiter, or 540 masses of the Earth. After that, adding more mass to a planet will make it smaller, because the compression becomes stronger. In other words, our little thought experiment is impossible.
What happens when a star runs out of its fuel? First of all, paradoxically, it grows to 1,000,000 times its original size. You see, when the core of a star runs out of hydrogen, it starts contracting under the weight of its own gravity. But some hydrogen fusion continues in the upper layers. While the core contracts, it heats up. This causes the upper layers of the star to heat up too and expand. The radius of the star increases. As the star grows, it engulfs any matter, even its own planets, in its wake. Astronomers have watched stars right before or straight after swallowing entire planets, but until recently, they have never seen the process itself. Scientists from different universities have reported that for the first time in history, they've observed a star swallowing a planet. And this tragic event happened not somewhere in a faraway galaxy, but in our own Milky Way, some 12,000 light years away from us. Astronomers spotted an outburst from a star, which is around 0.8 to 1.5 times the mass of our Sun, near the eagle-like constellation Aquila. It became over 100 times brighter than usual in a mere 10 days. And after that, it quickly faded away. Even more interesting, this white-hot flash was followed by a longer-lasting signal that was also colder than the first flash. And this combination, my friend, could only mean one thing. The star engulfed a nearby planet. What planet was it? Astronomers believe it could be a boiling hot world from 1 to 10 times the mass of Jupiter. Such planets are also called hot Jupiters. They're giant exoplanets similar to the Jupiter we have in our solar system that need less than 10 days to orbit their stars. The planet we're talking about had been gradually spiraling toward the star until it was pulled into its atmosphere and, eventually, into the core of the perishing star. This galactic feast happened between 10,000 and 15,000 years ago when the star was about 10 billion years old. And given its respectable age, the swallow itself happened lightning fast, in one fell swoop. This is very different from other hot Jupiters, which were quite delicately nibbled by their stars. Astronomers aren't sure if there are any other planets orbiting this star, perhaps at a safer distance, but even if there are, thousands of years will probably pass before they become the star's main course or dessert. In any case, now that astronomers know what they should search for, they're going to be on the lookout for more cosmic gulps. Because one day, our planet, as well as part of our solar system, will suffer the same fate. Everything around us will be gone in a flash. But you may relax and breathe out. It won't happen for another 5 billion years. That's when the sun is supposed to burn out and expand so much that it will swallow the inner planets of the solar system: Mercury, Venus, Earth, and Mars. If people manage to colonize some other world by that time, which should be at least 10,000 light years away from Earth, they would be able to observe this catastrophe. The sun would suddenly become much, much brighter, and it would eject some material into space. It would swallow several planets, including Earth, before nonchalantly setting back to what it was. But stars are not the only things in the universe that swallow other space objects. There's another kind of cosmic monsters that munch on everything, even light. Have you guessed? Right. I'm talking about ruthless black holes. But what is more interesting, they not only devour stuff but also seem to spit it out. Not so long ago, scientists found out that the supermassive black hole at the center of our home Milky Way galaxy seems to be leaking. Why is it a game changer? Because it might mean that this black hole, called Sagittarius A*, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active, and this leakage may be the whole hiccuping while swallowing clouds of gas. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often happens around active black holes, surrounded by the material, pulled toward them by their immense gravitational pull. Some of this material gets into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches mini jets of matter. Fermi bubbles might be the result of the belches that happened around 2 to 4 million years ago. But recently, scientists have discovered another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now I'll tell you something even creepier. There seem to be black holes that might be eating each other. Well, kind of. They're actually trying to share their meal at the moment, but who knows what will happen in the near future. But let me go into detail. Astronomers have spotted 2 supermassive black holes, feasting on the cosmic material of 2 merging galaxies in distant space. These giants have been located with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, also known as ALMA. These telescopes are in northern Chile's Atacama Desert. Scientists originally used them to watch 2 merging galaxies located about 500 million light-years away from Earth. Astronomers have also noticed that 2 gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy, UGC 4211. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. Even though they aren't visible directly, the black holes are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Times will pass, and these black holes will start circling each other, and eventually they will collide, creating one, probably even bigger black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are kinda unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light years, which astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. Interestingly, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around black holes. Imagine how surprised astronomers were when instead of one black hole, they saw two of them, munching on the dust and gas stirred up by the massive space merger. The most important thing about this discovery is that it may mean that such black hole binaries are likely to be much more common than we previously thought. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves that occur when black holes collide. Such waves are also known as ripples in spacetime. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide exist in the universe.
Our Sun. Scenario 1. Something strange just happened now. Every TV channel, the news, they're all talking about a black hole that came closer to us, on the spot where our Sun used to be. You can even see an accretion disk, and the background of the sky looks kind of distorted, which means it got really close. Normally, black holes are so far away that we can't see them with the unaided eye. You can't even see them with a telescope directly. What's it doing here so close? And where's the Sun? Did the black hole swallow it? The Sun used to be in the center of our solar system, far enough not to burn us, but still close enough to give us light, warmth, and beautiful scenes when it rises in the east and goes to rest in the west. Hey, this one even rhymes. Well, it gave us life. The most massive body in our solar system contains 99.8% of its total mass. It's so wide, you could fit more than 1 million Earths inside of the Sun. Maybe our Sun turned into a black hole, but it's way too early for that to happen. I mean, that's how they form, when enormous stars come to the end of their life cycle and explode, which is called a supernova. They end up collapsing on themselves, becoming very small. It's a tiny size and a huge mass. That's what makes black holes' gravity so strong, and even light that comes too close can't escape. And all the stars in the universe are shrinking and will disappear at some moment. Our Sun loses 4 million tons of mass every second, and eventually, the only energy left in the universe will be generated by black holes. A black hole is surrounded by dust, gas, and radiation. The radiation is very dangerous, so we hope our planet won't come near it. Our solar system doesn't have light anymore. No light and no heat either, so even Mercury and Venus will probably get covered in ice pretty soon, not to mention Earth. Do I need to say nothing will survive this new ice age? The only salvation might come from the accretion disk that spins so fast it generates heat, but that's too many chances to take. Still, at least if the black hole has the same exact mass as the Sun before it, all the planets will remain in the same orbits, Earth included. But if it has a mass bigger than our Sun, which is something our scientists are currently trying to figure out, then bye-bye, solar system. It was nice knowing you. Scenario 2. Oh no, what's happening? It was supposed to be a nice sunny day, but now you see darkness descending so abruptly. How come it's night, yet the clock says it's 2 p.m., and the moon looks different? The TV reports say our Sun is gone, and due to some mysterious events, the moon is not orbiting the Earth anymore. It's in the center of our solar system now. We don't have much time left. Since the Sun is not in the center of our solar system, We now have 8 minutes and 20 seconds to become aware of it. It may take millions of years for the sun's energy to travel from its core to the surface, but 8 minutes and 20 seconds is exactly how long it takes for sunlight to reach Earth. The light takes a journey across 93 million miles, which is the distance that separates us from the sun. We're not in the habitable zone anymore. The habitable zone is the distance from a star, in our case, the sun, at which liquid water could exist on the surface of a planet. Now that the sun's gone, its light won't reach us anymore, and our planet will gradually become a frozen, lifeless rock. Who knows if we'll have enough time to come up with some technologies that would provide us with the solar energy we need to sustain life on Earth. If not, well, millions or billions of years later, scientists from some other civilizations would explore it, trying to find evidence if life ever even existed there. It would be the same as we do with Mars and other planets in our solar system, trying to figure out if they've always been lifeless or if there might be a sign that some organisms used to live there. Something else, also vital for our life, travels at the speed of light: gravity. Without the sun, for roughly 8 more minutes, the planets would continue circling the empty center of our solar system until the clock ticks and they finally drift somewhere into an unknown direction of outer space. Our moon doesn't have a strong enough gravity to keep us in place. It can't shine so brightly to give us warmth and support life. It's so far, we can barely see it now. Without the moon that peacefully travels close to our planet as it used to, we can see tides are getting lower incredibly fast. Oh, and it's becoming really windy. Winds are so much stronger and faster now. When things were normal, our planet sat at a 23.5-degree tilt, which is the reason we had changing weather and seasons. Now the tilt is so extreme, it's getting very cold, very fast. And our time is almost up. People are screaming, everyone's in panic. We still have maybe 1 minute left until we sink into eternal darkness. Scenario number 3. We're not sure what exactly happened and how the life we carelessly lived yesterday came to an end. No one could predict it, but it seems that, out of nowhere, a giant neutron star took the spot where our sun used to be. It's not something we'd recognize on our own. We just noticed something was different, and the sun kinda got smaller and weirder. The rest we heard on the news, and no one knows how it happened. Maybe our sun is somewhere behind the neutron star, or the star pushed it out of our solar system and into an unknown direction. A neutron star is the densest space object we know about. It has almost twice as much mass as our sun, but it's all squeezed into a star only 10 miles, 15 kilometers, across, which is about the size of a city on Earth. A neutron star forms when a huge star runs out of fuel. It collapses in a big explosion. Its very central region, the core, collapses, which is why every electron, negatively charged particle, and proton, positively charged particle, crush together into a neutron, which is either uncharged or neutrally charged. We're in a very tricky situation now, basically waiting for our end to come. This neutron star has gravity 2 billion times stronger than the one Earth has. This means our new sun will pull all the planets in our solar system towards itself and eventually destroy them. It's already started. For the first time that we know of, the planets are leaving their stable orbits, attracted by the powerful force of the neutron star. It's becoming chaotic pretty fast. And it won't stop there. A neutron star rotates more than 700 times every second, which is incredibly fast. Our sun rotates once every 27 days. So, after it destroys all the planets, including us, this star will continue whirling throughout the universe at about 1/5 the speed of light. Maybe it will slow down and fizzle out with time, but maybe not. After thousands of years, many neutron stars begin to slow down and blow out. But that doesn't always happen. If it meets another star, it will orbit it and start to feed off its atmosphere until it collapses at some point and turns into a giant black hole. Our sun was going to burn out anyway. Until the neutron star showed up, the sun was 4.6 billion years old, which was about halfway through its lifespan. It had already burned off about half of its hydrogen stores and had enough supplies for another 5 billion years. It was eventually supposed to end up the size of the Earth. After running out of fuel, it would have simply collapsed. It would have retained its enormous mass, but its volume was going to be similar to that of our planet. No sun, no life. So the result would have been basically the same. But this way, it would have been a slow process. Who knows if humans would even inhabit this solar system in those times? But with neutron stars, things move towards the end pretty quickly, and it's way more chaotic. If the neutron star was going crazy somewhere far away in another galaxy, we'd only see it in the shape of a distant flashing light that we call a pulsar. But this way, boom!
Now, did you know that our sun is actually green? Okay, I'm kidding. But in reality, it's all colors you can imagine at the same time. Wait, what? I know it sounds like a joke, but I'm being serious, can't you tell? In fact, our sun contains absolutely all the waves of the light spectrum. It's simultaneously red, blue, green, yellow, you name it. Where do you think rainbows come from? When sunlight gets reflected off water droplets in the air, it splits into a bunch of colored waves that we can see individually. And when they're all together, we see a white ray of light. Our eyes are unable to perceive the concept of all colors at the same time, so their combination seems white to us. Wait, you might say, why white? Isn't the sun yellow? Yep, it's yellow too, but please don't stare at the sun just to make sure. It appears white when we see it from the International Space Station. This is the sun's real color as our eyes perceive it. The sun gets a yellowish hue when its rays get scattered in Earth's atmosphere. Our atmosphere doesn't let the blue rays of the spectrum pass very well, but the red ones? Hey, sure, why not? By the way, that's why the sky seems blue to us. The atmosphere scatters the blue color all over the place. During sunrise and sunset, short blue waves get reflected, but the long red ones reach us perfectly. That's why we see sunsets as pink, orange, or red. But what would happen if the sun had a different color? To answer this question, let's quickly repeat what we've learned. 1. The sun has the whole color spectrum in it. 2. Our atmosphere is like blue rays? Nope. Red rays? Anytime. So you probably already guessed what would happen if the sun was, let's say, red. The whole world would look like it does during sunsets. Not bad, huh? We wouldn't even have to wait for the evening to admire the scarlet sky. Orange water and a bright red moon. Yeah, it would be darker than what we're used to, but still not bad. Oh, by the way, one day, the sun will actually turn red. When its life comes to an end, it will expand and gradually turn into a red giant before finally burning out. But it's not going to be so much fun for us. So let's hope we won't be around to see that moment. I know I won't. Hey, I've got a party to go to. Okay, now, what if the sun was green? Well, the truth is, the sun is green. So here's your dialogue.
Wait, are you kidding me? Didn't you just say that it's white?
Ooh, good job on that, by the way. Well, not exactly, bud. The sun just looks white, but technically, it has a temperature of around 10,000 degrees Fahrenheit, and the pink wavelength of the sun's spectrum corresponds to the green-blue hue. But to make sure that the sun is green, we need to drown out the rest of the visible spectrum. Then our atmosphere will let through a pure green color. And what'll happen then? Well, everything will be green, and everything will also be a bit darker. Well, face it, it's not easy being green. Okay, moving on. Now let's paint the sun blue. Blue stars actually do exist. They're called blue giants. Fortunately, our sun is not one of them. Why fortunately? Well, because if it was a blue giant, it would be a young, beautiful, unimaginably large, and very, very hot star. See, our red is hot, blue is cold logic doesn't apply to stars. The hottest stars are white and blue, and the coldest are yellow and red. Yeah, our sun is actually very cold compared to other stars. Now, take the average temperature in your city, but multiply it by hundreds of thousands. Yeah, we're struggling with global warming here, but global burning? No thanks, blue giants. Anyway, let's imagine that the sun turned blue. How would we see the world? Surprisingly, nothing would change. Remember how I said that the atmosphere scatters blue light? That's why, in this case, everything would remain almost the same. Maybe the sky would get bluer, but we wouldn't see much difference. And finally, the darkest, pun intended, option. What if our sun turned black? Stock up on lamps and candles because there is no more light. People use electricity all over the world 24/7. We also can't see the moon anymore. After all, we can observe it these days only because the sun's rays get reflected off of it. Now, the only thing we still have to illuminate our nights are stars, but they don't help us much. Good thing this scenario is totally unrealistic and there are no black stars, right? Well, yeah, there are no black stars, and still our sun will eventually become completely black one day. And I don't mean a black hole. I'm talking about black dwarfs here. You've probably heard of white dwarfs, maybe even seven dwarfs. When a star like our sun is about to finish its life, it expands and turns into a red giant, and then, gradually losing its upper layers, it turns into white dwarfs. Since they no longer produce fuel, they slowly cool down. All that remains is a small core, living out its life and burning bright. And when the star cools down completely, it turns into a black dwarf. But you've probably never heard of them. Why? Because, surprise, surprise, they don't exist. And no, I was not lying. The thing is, a star needs about 1 quadrillion years to turn into a black dwarf. And our universe is still a baby. It's only about 14 billion years old. So no star has reached this stage yet. Even the most ancient of them still emit a little light. That's why black stars are just a theory. And it's unlikely that we'll ever see such a star at all. But remember the famous saying, the stars that we see at night are already ghosts because their light has reached us only now. Well, that's a myth. They're all still alive. Why am I telling you all this? Well, let's imagine that our sun turned into a black dwarf. The entire solar system would immediately get plunged into absolute darkness. It would also be terribly cold. The moon would leave its orbit and crash into Earth. Wait, no. Let's overlook this moment and assume we're still alive. Fortunately, we wouldn't freeze instantly, as you might think. Earth's core has its own temperature, more than 9,000 degrees. But the temperatures on the surface of the planet would still immediately drop to 32 degrees Fahrenheit. The core would gradually cool down. Every 2 months, its temperature would drop by 2 times. In just 2 months, Earth's surface temperature would be minus 190 degrees, and in a year, it would reach minus 450 degrees. Most plants would disappear pretty quickly, not because of the cold, but because of the lack of photosynthesis. Others would live a little longer thanks to the oxygen still remaining in the atmosphere. And, oddly enough, trees would survive for a very long time. They have a slow metabolism and get sugar from the ground. The upper layer of the oceans would freeze very quickly. Fortunately, this thick crust of ice would insulate deep waters, so the entire ocean wouldn't freeze for some time. Marine creatures would be doing pretty well. They existed long before us and are already used to crazy temperature changes, the lack of oxygen and food, huge pressures, and other joys of deep-sea life. And what about us humans? Well, first of all, we'd start getting sick. Without vitamin D, people would face a huge number of different health problems. Also, our bodies need sunlight to produce melatonin. This melatonin helps us understand when we should go to bed and wake up. If people didn't have this hormone, their bodies would get very confused and wouldn't understand whether they needed to sleep or not. That would mean insomnia for many people. But we would still be able to survive. We'd have 2 options: to build giant submarines and go down into the depths of the ocean closer to Earth's core, or stay on the surface, living our lives in some location where we'd have sources of geothermal energy. In Iceland, for example. We could also settle near volcanoes. Their heat would be enough to warm us for a long time. Our vision would adapt to the dark, but at some point it would reach its maximum. So we'd need to get used to living in complete darkness. But who knows? Maybe we would adapt to this life too. So, which option would you prefer? Living at the bottom of the ocean in a submarine or on the surface near volcanoes?